All right, you are welcome back. So this is another edition of this machine learning training. We are looking at unsupervised learning under association. So we have to look at FP growth last time. So that was last class. So today we want to look at ECLAT. ECLAT simply means equivalent class clustering and bottom-up lattice traversal. So this is the meaning of ECLAT algorithm as one of the association-based unsupervised learning algorithm. Right? It is an association rule mining algorithm that uses vertical data format, list of transaction IDs per item. It employs intersection-based search to find frequent item sets. It also is faster than a priori for dense data sets, many frequent items. So it's a little bit faster than a priori we saw last time. So it's very easy to implement and very short. So here is a sample using the same data set we have used before. So I point the library again and I run it. I have my data show here. This is the true item purchase and transaction is true, right? Now I can convert to vertical format here. A class requires items mapped to transaction ID. So that's what we say ID say. So it is mapped to the ID, transaction ID, so per items. All right, so right, when I click on to confirm, each of them is converted to ID one by one. Bread, milk, eggs, and you can see each of the number of items here in vertical format, transaction made rather. So you can see to implement, we have to apply recursively find the frequent items by intersecting transaction sets. So when I run this one, we can see our item set support. So this one should be here anyway, but no problems. And we can see manage to fill like this. So we have our bread here, having the highest here, 86%, so to say. So and so on. So when there's a merge together, bread and butter, bread and butter here, we have 57% here, and butter only 57% as well. So you can say bread, milk, butter. So that is just the ECLAT. So can generate the association rules. So we filter rules by confidence and lift as we have done before. So when we filter confidence, we have our antecedent again, we have our consequence, we have our support, we have our confidence, and we have our lift. You can see the higher the lift, the better it is. Okay, the stronger the association, that's what it means. Okay, so here we have our lift 1.3 here, 1.3 here. All right, so we are having our for here we have our milk, egg, we have 75% confidence interval. But we have 1% confidence here for bread. Okay, 1% confidence here for bread. All right, and the antecedent is butter. 1%, 1%. I mean 100% rather, 100% rather. So this 100% give us so the higher bars. You can see here we're having a confidence interval here. So these are what you have down. If you move down, we have our selection here. We have our item set here. So you can see them around it. So we have egg and bread. We have egg and milk. We have egg only. We have butter and bread. We have butter only. You can see here. So it's just what we have done before, but now a different way of handling it now. So you can associate association rules. Association rules network can be also displayed here. We have association rule network here, edge thickness is called and lift. So we have our end set here: butter, bread, milk, okay, egg. So this the beginning of the song is at the end set. So we have it flows like that in that direction. So that's our. You can see that everything is pointing to bread here: bread, bread, bread. It's an association between butter and bread, between milk and bread, between eggs and bread. You can see so, which means that is our bread. So the key concepts here is that the FT growth automatically creates the correctly formatted data frame. Association rules receive the expected column names and data types. The items column contains proper frozen set objects. for us to actually itemize, for us to custom item set, like from ECLAT, we ensure that we rename columns exactly to item site and support. We have to rename the column, rename our column in our own personal one. I mean, our data set. If you want to do it, we rename the columns to item set and support so that they can follow the same output. Convert item set to frozen object. Vertical format, we have ECLAT uses item to transaction and transaction mapping for efficiency. Intersection based defines frequency item set by intersecting transaction IDs. No candidate generation faster than a priori for data sets. So parameter that are commonly used there is minimum support, which controls how frequent an item set must be, and we also have a minimum confidence, which filters the meaningful rules. So we want to use this. We have what we call dense data data set, many frequent item sets, small to medium transaction database. So within small to medium database is okay, and when a priority is too slow, you can apply ECLAT. For a very large data set, we are about to consider FP growth instead. All right. If you like to try this on data set, you can try it. So just supply your data set in there and see how it goes. And this is just a simple example here, and you can see how it goes. All right, it's very simple. That's why I don't waste much time on it. Very simple, very easy, not like the first one we did last time. All right, so thank you so much for watching and listening. We'll see you in the next class.